All matter in the universe originated with the Big Bang. Shortly after the Big Bang, the universe cooled enough to allow for the formation of protons and neutrons, and then elements. Only hydrogen and helium were formed at this time, about a 75% hydrogen to 25% helium ratio, which is still seen all over the universe today. Only hydrogen and helium formed, and when the universe cooled further, formation stopped. The formation of heavier elements would occur later in the history of the universe. Elements heavier than helium were formed by stars. Nuclear fusion occurs in a star, combining lighter elements to form heavier elements. This process begins with hydrogen fusion and ends with the formation of iron. Elements heavier than helium and hydrogen were formed from fusion in the core of a star. Elements heavier than iron are still formed by stars. These elements are the result of a supernova. Supernovas are the death of a large star. The inner core collapses and the outer layer of the star explodes. This creates enough energy to form elements heavier than iron. An example to connect it all. Carbon, an element vital to life on Earth, began as hydrogen or helium shortly after the Big Bang, from matter released by the Big Bang. Then hydrogen and helium fused in the star to form heavier elements. Carbon was formed in the fusion process. The carbon was then deposited on Earth, or was a component of the gas cloud forming the solar system and used by life today on Earth. Some scientists believe that life could have began at an alkaline hydrothermal vent. These vents release fluid at 90 degrees Celsius to 45 degrees Celsius and a pH of 9 to 11. Reactions that would have used the energy gradients produced when fluid mixes with the acidic seawater. Ancient oceans are believed to have been much more acidic than current oceans, along with minerals naturally present to reduce carbon dioxide to produce organic molecules. These molecules would lead to the first forms of life. UV light can be used to produce molecules necessary to life. This reaction begins with hydrogen cyanide and hydrogen sulfide. When exposed to UV light, these chemicals react to form RNA nucleotides. Early life could have used zinc sulfide as a catalyst to reduce carbon dioxide, an early form of photosynthesis some call a zinc world. According to Nick Lane, who is a biochemist at the University of London, this hypothesis is incorrect. Lane argues that this is not how life formed because today life does not use UV light as an energy source. UV light, quote, tends to destroy molecules rather than promote biochemistry, end quote, according to Lane. He also argues that although this chemistry works, it would be unlikely for it to align with the current life on Earth. The ocean would provide a much better habitat for life to form in the absence of UV light. The water would block light from entering and protect life from damaging UV rays. Areas such as around hydrothermal vents, as previously mentioned, provide an area without exposure to UV light and provide the conditions necessary for life to form.